I am taking a 3D digital cast of my foot. It's a fairly unusual way to be using an Orthema digitizer. We tend to pronate on neutral slightly to ensure that we're getting a lower arch profile, and we will also look at doing some modification in the software later to ensure we don't have any excess support lateral to this supposedly massively medially deviated and translated subtalar joint axis. So obviously we'll draw the patient's subtalar joint axis on the plantar aspect of the foot, take a two-dimensional image, and then we're going to overlay that onto the three-dimensional image to give us an idea of where we want to be placing our MOSI, our rear foot skive. So here we have a quick shot of the rather dodgy looking axis. So I'm going to attempt to talk you through what we're doing. We've got our two-dimensional representation of 3D image. We want to centralize that, make sure it's in a nice tidy place. We'll go through and we're going to create a prescription. So we're going to grab that two-dimensional image, that photo that we took earlier, and overlay it. We can play with the transparency and we can line it up with the two-dimensional representation of the 3D image. So it's quite nice to be able to do this in front of the patient so we can describe what we're doing, why we're placing this here, and how this is going to be beneficial to them. On this particular machine, we're running, first of all, some screen capture software that's slowing it down unbelievably, so the rendering's appalling. And also I've used just a standard shape that gives us a mild representation of this 45-degree shape that we have created as a custom shape on the other box. As you can see, the rendering is appalling. You can see our MOSI just sitting here, and this is the shape without any modification to it. The digitizers and the milling machines don't require very clever PCs at all. So we're not using heavy graphics workstations at all. These renderings almost always occur within literally a quarter of a second, where we're seeing it taking 2 or 3. So here I am in the saved file name describing the characteristic of the device I'm after. So a 50 Shore blank, 2mm thick, 2mm heel raises, high cups. So once we've dealt with all those characteristics that we're after in the file name, then we're going to go onto the milling menu, choose those characteristics, 2mm thick, 2mm heel raise. We're going to zero out any sulcal information because we want to have a device that's flat from the metatarsal heads forwards. So here we are with, I believe, a high cup with our MOSI. We're looking at from behind. You can see we've got a high cup. We want to be careful of that lateral border, obviously, in this situation. Here we are with a low cup, much more like what we're after, but we do need to reduce that ILA quite considerably, and I don't think I did for you on this video. So we remove the adhesive backing, place the blank in the mill, close the doors, press go. 5 minutes later we have a device coming out of the mill that needs 2 minutes finishing to allow us to dispense a device. I'd like to say a great thank you to Harradine, Collins, Webb and Bevan for describing this for us, and I hope you all enjoy this little video I put together for you. Thank you.